The research introduces FLAME, a novel multimodal large language model (MLLM)-based agent designed for urban vision and language navigation (VLN) tasks. It addresses the limitations of current LLMs in navigation-specific scenarios by proposing a three-phase tuning technique. The first phase focuses on single perception tuning for street view description, the second on multiple perception tuning for trajectory summarization, and the third involves end-to-end training on VLN datasets. The approach utilizes GPT-4 for synthesizing captions and route summaries, enhancing the agent's navigation capabilities. Experimental results demonstrate FLAME's superiority over existing methods, achieving a 7.3% increase in task completion rate on the touchdown dataset. This work showcases the potential of MLLMs in complex navigation tasks, representing an advancement towards practical applications of MLLMs in embodied AI. The proposed model, FLAME, is an advanced navigation system designed for urban environments. It integrates vision modules for observation processing and decoder blocks for instruction and history handling. The model utilizes strided cross-attention to prioritize recent observations, enhancing its proficiency in identifying and responding to significant features in the environment dynamically. FLAME undergoes a three-phase tuning paradigm to adapt FLAMingo for urban VLN tasks. The first phase, single perception tuning, focuses on developing the model's feature recognition abilities through street view captioning tasks. The second phase, multiple perception tuning, aims to synthesize information from sequential observations, crucial for navigation understanding. The final phase, end-to-end navigation tuning, fine-tunes FLAME on the VLN dataset, enabling it to effectively process navigational instructions and environmental cues. To support the fine-tuning of FLAME, the authors leverage large language models, LLMs, to automatically synthesize street view captions, route summaries, and navigation rationales. These synthetic data are generated using GPT-4 and GPT-4v, providing diverse and comprehensive knowledge graphs of landmarks. The rationale generation process involves segmenting each VLN trajectory into subroutes between key locations, then retrieving the corresponding image caption and subroute summary for each key location. This results in an altered subset of the VLN dataset augmented with synthetic rationales, facilitating end-to-end training with reasoning capabilities. The paper presents a novel approach to vision and language navigation, VLN, tasks, introducing FLAME, a multimodal language model, MLLM, that integrates visual and textual information to navigate through urban environments. The model is evaluated on two datasets, Touchdown and Map2Seq, and achieves state-of-the-art performance on both. The authors compare FLAME with previous state-of-the-art models, including RCONCAT, GA, VLN Trans, ARC plus L2S, or R, Velma, and Log4 Plan. FLAME outperforms these models on both datasets, demonstrating its superiority in comprehending navigational instructions and environmental cues. The paper also introduces two new metrics, rationale coherence, RC, and rationale action alignment, RA, to evaluate the agent's reasoning capabilities. These metrics assess the consistency and alignment of the agent's rationales with its actions. The results show that FLAME achieves high scores on both metrics, indicating robust rationale generation and strong consistency. The authors investigate the effect of decoding temperatures and paths on FLAME's reasoning performance. They find that increasing the number of decoding paths improves the model's performance, especially on the touchdown dataset. They also demonstrate that FLAME's calibrated evaluation method reduces discrepancies between automatic and human evaluations. Additionally, the paper analyzes the effect of the strided cross-attention module on FLAME's performance. The results show that increasing the stride size generally correlates with a decrease in task completion rates, highlighting the importance of prioritizing current observations in decision-making processes. Overall, the paper demonstrates FLAME's advanced decision-making capacity and its ability to generate diverse rationales, leading to improved navigation performance. The proposed approach has the potential to significantly impact the field of VLN, enabling more effective and efficient navigation in complex environments. In this paper, the authors introduce FLAME, a multimodal language model, MLLM, designed for urban vision and language navigation tasks. The proposed model utilizes a novel three-phase tuning technique and synthetic data to achieve state-of-the-art performance in urban VLN. FLAME demonstrates superior ability to integrate verbal and environmental cues for decision-making, as evidenced by comparison results and reasoning performance. The paper also presents a comprehensive analysis of the effectiveness of the proposed tuning technique and other components. This includes an ablation study of three-phase tuning for navigation, which shows that the first-phase tuning yields improvements in TC for both touchdown and map2-seq datasets, suggesting enhanced environmental familiarity. Implementing the second phase of tuning leads to optimal performance across both datasets, highlighting the importance of tuning with sequential observations. A qualitative analysis of FLAME's navigation capabilities is provided, showcasing the model's proficiency in following instructions and capturing salient environmental details. This is demonstrated through a comparison with the baseline method, where FLAME successfully completes the navigation task while the baseline fails at the fourth intersection. The paper concludes by discussing the potential of multimodal LLMs in complex navigation tasks. It also provides an extensive list of references, including works on vision and language navigation, multimodal language models, and other related research. The references section covers various studies on vision and language navigation, multimodal language models, and other related research. These include papers on speaker-follower models, multimodal discriminative models, interleaved multi-image instruction tuning, and open web-scale filtered datasets of interleaved image text documents. The section also includes studies on the importance of phased learning, the role of multimodal language models in navigation, and the impact of tuning with sequential observations. Here is a combined summary of the 2 pages, covering all major points, novel ideas, significant findings, and important arguments presented. This collection of research papers focuses on vision and language navigation, a task that involves navigating through unseen environments using natural language instructions. The papers explore various approaches to improve the performance of large language models in this task. Several papers investigate the use of multimodal learning, where models are trained on both visual and textual data to learn joint representations. For example, Li et al. 2022a propose CLEAR, a model that uses cross-lingual and environment-agnostic representations to improve vision language navigation. Lin et al. 2024a introduce NavCot, a method that boosts the performance of large language models by learning disentangled reasoning. Other papers explore the use of large language models as a foundation for vision language navigation. Wang et al. 2023 propose Cosmos 2, a model that grounds multimodal large language models to the world. Tuvron et al. 2023 introduce Llama, an open and efficient foundation language model. Some papers focus on improving the evaluation of vision and language navigation instructions. Zhao et al. 2021 propose an evaluation framework that assesses the quality of navigation instructions. Schumann et al. 2022 analyze the generalization of vision and language navigation to unseen outdoor areas. Several papers also investigate the use of chain-of-thought reasoning in large language models. Wei et al. 2022 introduce chain-of-thought prompting, which elicits reasoning in large language models. Wang et al. 2023b propose self-consistency, a method that improves chain-of-thought reasoning in language models. Finally, some papers explore the use of memory and reasoning chains to improve vision language navigation. Zhan et al. 2024b propose McGPT, a model that empowers vision and language navigation with memory maps and reasoning chains. Zhou et al. 2024 introduce NAVGPT-2, a model that unleashes navigational reasoning capability for large vision language models. Overall, these papers demonstrate the progress made in vision and language navigation, highlighting the importance of multimodal learning, large language models, and chain-of-thought reasoning in this task.